Hello students, once again welcome you to GK's maths classes. Today this is the part 2 video of differentiation where we are going to do differentiation of inverse trigonometric function. Already we have introduced you to inverse trigonometry. Maybe I'll put the link of those videos in the description box for your understanding. So today what we are going to do is we are going to differentiate inverse trigonometric functions. Okay, so let's straight away get inside the video. We are going to do quite a few problems today from NCERT as well as from outside the book, which has come in the board exam. As usual, these are the formulas that I have given you last class. So I'm just putting it for your reference so you can have a look at it. These are the various formulas on differentiation. Now let's go to the first problem. Now here the question is differentiate tan inverse of root of 1 plus sin x by 1 minus sin x. As you know, you cannot differentiate it directly. You need to simplify it. You have to reduce it to the simplest form. So what I do first is, first let me write this as a function of y. Y equal to tan inverse of root of 1 plus sin x by 1 minus sin x. Okay. Now since this is tan inverse, I want to bring this in terms of tan. This should be brought in terms of tan. So let's see how to do that. So can I say this is tan inverse of square root of, I'm simplifying it, I will write this as cos 90 minus theta. Am I right? Sin theta is cos 90 minus theta. So what do you say about this? This will be 1 minus cos of 90 minus theta. Okay, or in fact, if you can write cos 90 plus theta, then I can put a minus sign here, and if I put 90 plus theta, I can put a plus sign here. Why? Because you know cos 90 plus theta, it's in the second quadrant. Second quadrant cos is negative, so I get minus sin x. So it becomes much easier and shorter. So sin 90, cos 90 plus x is minus sin x. Already there's a plus sign, so plus into minus is minus. And cos 90 minus x is minus sin x. Already there is a minus sign. Minus into minus is plus. You also know that 1 minus cos 2a, the formula is 2 cos square a. Sorry, 2 sin square a. And 1 plus cos 2a, the formula is 2 cos square a. I'm going to use these formulas. So what do? This becomes tan inverse of, can I say the numerator is 2 sin square, half of this, that is pi by 4 plus x by 2. Yes, because 2a becomes a, half. So pi by 2 plus x will become half of it. That is pi by 4 plus x by 2. Divided by 2 cos square pi by 4 plus x by 2. So it's very simple. 2 gets cancelled. So this will become tan inverse of, can I say this is tan pi by 4 plus x by 2? I'm removing the square root. Why? Sin square by cos square is tan square. Root of tan square is tan. What is tan inverse of tan pi by 4 plus x by 2? It is pi by 4 plus x by 2. So I have reduced this to the simplest form. Now what is dy by dx? Differentiation of pi by 4. Pi by 4 is a constant, so it is 0. Differentiation of x by 2. 1 by 2 is a constant. Differentiation of x is 1. So very simple, just application of trigonometry. Okay. Let's go to the next question. Differentiate tan inverse of 1 plus x square by 1 minus x square. Okay. Now how do I do this? So let's first write this as tan inverse of 1 plus x square by 1 minus x square. It is very tempting for me to put x as tan theta, so it looks like cos 2 theta. But this is tan inverse, so no point in getting anything in terms of tan or in anything in terms of cos or secant. I should get only in terms of tan. So for that what I do, I will take x square as tan theta straight away. By taking x square as tan theta, see what exactly happens. This becomes tan inverse of 1 plus tan theta, because I have taken x square as tan theta, by 1 minus tan theta. Now what is this? This is tan inverse of, can I write this 1 as tan pi by 4 plus tan theta divided by 1 minus, see, you can always have into 1, no issues, right? So it is tan pi by 4 tan theta. So what is tan A plus tan B by 1 minus tan A tan B? It is tan inverse of tan A plus B. Now what is tan inverse of tan pi by 4 plus theta by 2? It is pi by 4 plus theta, which is pi by 4 plus, what is theta in terms of tan? Theta in terms of tan is tan inverse of x square. So I have reduced this to the simplest form. Now it's time to differentiate. Now how do I differentiate? Dy by dx. Differentiation of pi by 4 is 0. You know differentiation of tan inverse x is 1 by 1 plus x square. Remember, tan inverse x differentiation is 1 by 1 plus x square. But it is tan inverse of x square. So what will be that? 1 by 1 plus x power 4. X square the whole square. I hope you get that. After differentiating tan inverse by chain rule, differentiation of x square will be 2x. I hope you know chain rule is, okay? So 1 by 1 plus x power 4 into 2x. So finally you can write 2x by 1 plus x power 4. Very simple question, but if you try to differentiate directly, it gets complicated. Always reduce it to the simplest form before differentiating for the inverse trigonometry. The next one, this is an NCERT question. I have y equal to tan inverse of, this is root of 1 plus x minus root of 1 minus x by root of 1 plus x plus root of 1 minus x. Since I have 1 plus x and 1 minus x, it is advisable to put x as cos theta, or you can put it as cos 2 theta, doesn't matter. I put it as cos theta. So what do I get? So I get tan inverse of root of 1 plus cos theta minus root of 1 minus cos theta divided by root of 1 plus cos theta plus root of 1 minus cos theta. So wherever x is there, I put cos theta. Now you know the formula, right? What is the formula? The formula is root of, you know this formula, right? So let me have it. I'll be using it again and again. So here I'm going to use this formula. Let me keep it here. So what is this formula? Y equal to tan inverse of square root of 2 cos square theta by 2 minus square root of 2 sin square theta by 2 divided by square root of 2 cos square theta by 2 plus square root of 2 sin square theta by 2. I just apply this formula here. And you see clearly root 2 is common throughout, root 2, which can be cancelled. So I get tan inverse of, clearly you can take it out, take out root 2. This is cos theta by 2 minus sin theta by 2. I am removing the root, okay, divided by, you can say root 2 is common. You have cos theta by 2 plus sin theta by 2. They get cancelled. Now what I do, I divide numerator and denominator by cos theta by 2. When I do that, see what happens. I get y equal to, I have tan inverse of, if I divide by cos theta by 2, I get 1 minus tan theta by 2 by 1 plus tan theta by 2. So because I am dividing numerator and denominator by cos theta by 2. So this is y equal to tan inverse of, what is this one? 1 is tan pi by 4 minus tan theta by 2 divided by 1 plus, you see there's a 1 here which can be replaced as tan pi by 4 tan theta by 2. So this is my tan A minus tan B by 1 plus tan A tan B, and what is that equal to? This is tan inverse of tan pi by 4 minus theta by 2. So what is tan inverse of tan pi by 4 minus theta by 2? It is pi by 4 minus theta by 2, which is pi by 4 minus 1 by 2 into, what is theta? Theta is cos inverse of x. Now I am going to differentiate. Differentiation of pi by 4 is 0. Minus 1 by 2 is a constant which remains as it is with the variable. Differentiation of cos inverse of x is minus 1 by root of 1 minus x square. So it is plus 1 by 2 root of 1 minus x square. So first you need to simplify it. First you have to do inverse trigonometric function simplification, then only you can differentiate. If you try to differentiate directly, it becomes very complicated. Okay. Now the next problem. All these are important questions. This is tan inverse of root of 1 plus x square minus 1 divided by x. Okay. Now what I will do, whenever you have 1 plus x square, I have told you that you can put x as tan theta or cot theta. In this case, I'll put x as tan theta. You know the reason, because 1 plus tan square is secant square. So you get tan inverse of root of 1 plus tan square theta minus 1 divided by tan theta. This is tan inverse of root of 1 plus tan square theta is secant theta. Actually secant square, root of secant square is secant minus 1 divided by tan theta. Now convert everything to sine and cos. When you convert everything to sine and cos, what do I get? Tan inverse of secant is 1 by cos, tan is sine by cos. Now take LCM, what do you get? Y equal to tan inverse of 1 minus cos theta divided by sine theta. I took LCM, cos and cos gets cancelled. But again, you know, I am using this formula. What is 1 minus cos theta? We keep using this again. Tan inverse of, it is 2 sine square theta by 2. 2 sine square theta by 2. I am using this. And what is sine 2a formula? Sine 2a formula is 2 sine a cos a. So this will be 2 sine theta by 2 cos theta by 2. Okay. Let me just copy this and keep. I may need it. Okay. So this will be y equal to tan inverse of 2 gets cancelled, sine gets cancelled. So I get tan theta by 2. So what is tan inverse of tan theta by 2? Very nicely it comes, right? Theta by 2. And 1 by 2 into, what is my theta? Theta is tan inverse of x. So what is dy by dx? 1 by 2 is a constant with the variable, so I keep it as it is. Tan inverse of x is 1 by 1 plus x square. Simple. Again you see, simplify then differentiate. Simplification not very difficult. If you follow the procedure, you'll get the answer. This is again an NCERT question in inverse trigonometry, but they can ask in differentiation also. So how do I go about it? So y equal to cot inverse of root of 1 plus sin x plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x. This is slightly lengthy, but it's not difficult. So what I will do here is, there are different ways to do. I prefer to do this method. I write one as cos square x by 2 plus sin square x by 2. So my sin can be written as 2 sin x by 2 cos x by. I am using sin 2a formula. Okay. Now similarly, this is 1 cos square x by 2 minus sin square x by 2, it's actually plus, and this is minus 2 sin x by 2 cos x by 2. Okay. Now what will happen in the denominator? Before that, I will copy this. Again, I have to write. I wrote it down. So this can be changed to minus sign. Okay. So this will be y equal to cot inverse of, now this is cos x by 2 plus sin x by 2 the whole square. So if you remove the square root, it becomes cos x by 2 plus sin x by 2. I remove the root, and this is cos x by 2 minus sin x by 2. Denominator will be cos x by 2 plus sin x by 2 minus cos x by 2 minus sin x by 2. Now clearly these two gets cancelled, and you can see clearly cos gets cancelled. So I am left with cot inverse of 2 cos x by 2 by 2 sin x by 2. So you can cancel the 2. Cos by sin is cot. So I get cot inverse of cot x by 2. Now cot inverse of cot x by 2 will be x by 2. So I have got y equal to x by 2. So what will be my dy by dx? 1 by 2 is a constant, and differentiation of x is 1. So it's very, very easy. Okay. So again, if you don't simplify it, our differentiation gets very complicated. Okay. Very, very important type of questions. Just let me have a sip of water. Very, very important type of question. Sorry. Okay. This is y equal to tan inverse of 5ax divided by a square minus 6x square. Whether it is a tan 2a formula, tan a plus b formula, or tan a minus b formula, the denominator always begins with 1. You see tan a plus b, tan a plus tan b by 1 minus. If you look at tan 2a formula, 2 tan a by 1 minus. So always the denominator starts with 1. So you should aim for getting 1 there. How do I get that as 1? Divide numerator and denominator by a square. When you divide numerator and denominator by a square, what do I get? I get tan inverse of, I am going to divide this by a square. So a gets cancelled. You get 5x by a by 1 minus 6x square by a square. Now keep one interesting thing in your mind, that denominator is minus. Denominator, there is a minus. So I have to write this in terms of plus. So what I will do, I will write this as 3x by a plus 2x by a, which is nothing but 5x by a. At the same time, if you notice, the 6x square by a square can be written as 3x by a into 2x by a. So now you can see some sort of a pattern. What is the pattern? 3x by a, I call it as tan a, and 2x by a, I call it as tan B. Okay. Now take this and substitute. So I get y equal to tan inverse of, what do you get here? Tan A plus tan B divided by 1 minus tan A tan B. Correct? Now what is tan A plus tan B by 1 minus tan A tan B? It is nothing but tan of A plus B. What is tan inverse of tan A plus B? It is A plus B. So what is A? My A will be tan inverse of 3x by A. What is my B? Tan inverse of 2x by A. Okay. So I have written it in a very simplest form. Now I am going to differentiate. Dy by dx. What is differentiation of tan inverse? 1 by 1 plus this square. What is this? 3x by A whole square. So I have differentiated tan inverse. Now what I have to differentiate? I have to differentiate 3x by A. 3x by A, how do I differentiate? 3 by A is a constant. Differentiation of x is 1. Okay. Plus 1 by 1 plus this square, which is 2x by A whole square into, what is differentiation of 2x by A? 2 by A is a constant. Differentiation of x is 1. Now take LCM. This will become A square and this A square will come up, divided by A square plus 9x square into 3 by A plus, again this will be A square will come up, LCM A square plus 4x square into 2 by A. Now A and A cancels, A and A cancels, and you got the answer. You see 3A by A square plus 9x square plus 2A by A square plus 4x square. Very simple. Again, as I said, differentiating this directly, very difficult to get to this answer. So you have to reduce it to the simplest form. Understand the technique, it's not at all difficult. Let's go to this very simple question. Y, very, very important also. Y equal to cot inverse of root of 1 plus cos 3x by 1 minus cos 3x. Okay, let's go back to the page where I need the formula. Okay, I'll take this formula, otherwise I have to keep writing it. Okay, I need this. Look at this. I will use the same formula here. So y equal to cot inverse of root of 2 cos square 3x by 2 by 2 sine square 3x by 2. 2 gets cancelled, right? So I get, if you know the formula, it's direct. There's nothing to even think. Cot inverse of, this is nothing but cot 3x by 2. I'm removing the square root, the square will go. So y equal to 3x by 2. This becomes so simple. Now what is differentiation of this? 3 by 2 is a constant and differentiation of x is 1. You see, if I try to differentiate this directly, it becomes a mega project. Whereas when you simplify it, it becomes very simple. You save a lot of time and your energy also. Okay. Now let's go back to the next question. This is tan inverse of, I think I already did this problem, so I'll skip this. I'll go to this. Y equal to 2a power x by 1 minus a power 2x. So I'll write the question. Tan inverse of 2a power x divided by 1 minus a power 2x. Correct? So what do? Put a power x as tan theta. So I get y equal to tan inverse of 2 tan theta by 1 minus a power 2x. A power 2x is nothing but tan square theta. Am I right? Because tan square theta is a power x the whole square, which is a power 2x. Okay. So this is a very familiar formula to me. This is nothing but tan 2 theta. Tan inverse of tan 2 theta is 2 theta. And what is theta? Tan inverse of a power x. So what is dy by dx? Watch out careful. 2 is a constant. Differentiation of tan inverse is 1 by 1 plus a square. A square, x square. A power x whole square. X square. Okay. Into what is differentiation of a power x? Differentiation of a power x is a power x log a. So that's the form. Okay. Maybe I'll just do one more question similar to this, which is there I think in the NCERT book. Say for example, I want to differentiate what question I should ask? 4 power x plus 1 by 1 minus 16 power x. I think no, I don't remember the question, so I'll do it in the next video, whatever it is. Okay, I don't remember the exact question. 2 into 2 power x. Yeah, I think I remember it. Tan inverse of 2 to the power of x plus 1 divided by 1 minus 4 power x. So what do I do? This is tan inverse of, I can write this as 2 into 2 power x divided by 1 minus 2 power x the whole square. So what exactly is this? This is a power m plus n is a power m into a power n, and 4 power x is nothing but 2 square the whole power x, which is 2 power x the whole square. Okay, I think algebra, you know it. Now what do you do? As usual, you put 2 power x as tan theta. So I will get y equal to tan inverse of 2 tan theta divided by 1 minus tan square theta, which happens to be tan 2 theta. What is tan inverse of tan 2 theta? 2 theta, which is 2 into tan inverse of 2 power x. Now how do I differentiate this? Keep 2 as it is. What is differentiation of tan inverse? 1 by 1 plus 2 power x the whole square, okay, into a power x log a. Here my a is 2, just like this. Now if you can further simplify this to 2 power x plus 1 log 2 by 1 plus 4 power x. Both are exactly same. It is slightly in a different form, that's all. Okay. Both are important. Now the next question, this is a very nice problem. Okay. Let me zoom this a bit. So what is this? Y equal to a tan inverse of x by 1 plus 6x square. So denominator is plus. If the denominator is having 1 plus 6x square, I should write the numerator as what? It should be written as 3x minus 2x. Am I right? 3x minus 2x is x. At the same time, what happens to the denominator? The denominator will be 3x into 2x, correct? Now there is a pattern, okay? So I can put 3x as tan A, and I can put 2x as tan B. So you get y equal to tan inverse of tan A plus tan B divided by 1 minus tan A tan B. Now what is tan A plus tan B by 1 minus tan A tan B? It is tan inverse of tan of A plus B. So what is tan inverse of tan of A plus B? It's A plus B. What is A? tan inverse of 3x, and what is b? Tan inverse of 2x. Done. Okay. See, I did not do any difference. I brought it to the simplest form. In fact, we are revising inverse trigonometric function. dy by dx. What is differentiation of tan inverse? It is 1 by 1 plus this square, that is 9x square, into what is differentiation of 3x? Differentiation of 3x is 3, plus what is differentiation of tan inverse of 2x? It's 1 by 1 plus 4x square. And what is differentiation of 2x? Differentiation of 2x is 2. So that's the answer. It is something similar to the problem which we did today, like, which one is that? This. Is this the one? This is similar to this problem. Okay. Here it is having a and all that, but here without that. Okay. Now let's go to the next question. Very simple, very beautiful 1 mark question. Okay, let me just zoom in a bit for you to see things clearly. You can see. What is this? Y equal to secant inverse of x is nothing but cos inverse of 1 by x. So here it will be cos inverse of x minus 1 by x plus 1. See, I take reciprocal. Secant inverse of x is cos inverse of 1 by x. This is what? Sine inverse of x minus 1 by x plus 1. Now both are same. So you know that sine inverse of x plus cos inverse of x is pi by 2. So if these two are same, it is pi by 2. You hear these two are same. So what is this equal to? Pi by 2. So what is dy by dx? Differentiation of constant is 0. 1 more question. They can ask you with tan. They can ask you with tan and cot. They can ask you with cosecant and what else? And secant. So be careful with that. Okay. Okay. Next question. Very important. It has come in the board exam also. So if you observe this problem carefully, these three numbers are very exciting. 5, 12 and 13 form a Pythagorean triplet. They will represent a right angle triangle. So this will be sine inverse of, can I say this is 5 by 13 x plus 12 by 13 root of 1 minus x square. Okay. Now what I will do, I will take x as sine theta, because I have to take this as y. So I will get sine inverse of, now x is sine theta, and I have 5 by 13 plus 1 minus sine square. 1 minus sine square theta is cos square theta. Root of cos square theta is cos theta. Is it okay? I am skipping one step. 12 by 13. Now let me draw a Pythagorean right angle triangle and call this angle as A. This is sine. I want this entire term in terms of sine. This looks like sine A cos B plus cos A sine B. So this has to be cos. So adjacent by hypotenuse. So obviously this is 12. So looking at this triangle, what do I get? Sine inverse of sine theta, and 5 by 13 is cos A, and 12 by 13 is sine A. What formula is this? Sine inverse of sine A cos B plus cos A sine B. So it is sine of A plus B. Now what is sine inverse of sine theta plus A? Sine inverse of sine theta plus A is theta plus A. And what is theta? Theta is sine inverse of x. A I don't care because A is connected with constants. So A is a constant. So whether I take it as sine A or cos A or tan A doesn't matter. Because A is a constant because it's a right angle triangle with constant numbers. So dy by dx will be, differentiation of sine inverse of x will be 1 by root of 1 minus x square, And as you know, a is a constant, so differentiation of constant is 0. I hope you understand why it is a constant, because this a is associated with numbers 12, 13 and 5, which are constants. So a is a constant. It's a very, very important type of question. Now let's go to this another very nice sum. Okay. Here what I do, I take x as cos theta. I remember I told you, right? When you have 1 minus cos theta and 1 plus cos theta, always do that. Now let's come back to this usual formula. What is that? Sine of 2 tan inverse of root of 1 minus cos theta by 1 plus cos theta. This is y. So y equal to sine of 2 tan inverse of, this is 2 sine square theta by 2 by 2 cos square theta by 2. 2 and 2 cancels. This is sine of 2 tan inverse of tan theta by 2. I remove the square root. So this is y equal to sine of 2 tan inverse of tan theta by 2 is theta by 2. So they get cancelled. You get sine theta. The sine theta is root of 1 minus cos square theta. So cos square theta is 1 minus x square. Right? So I have simplified this to this. Now you differentiate. Chain rule, dy by dx. In chain rule, what do I differentiate first? I differentiate the square root. What is that? 1 by 2 root of 1 minus x square. After differentiating the root, I go inside. What do I see first? I see 1. Differentiation of 1 is 0. No need to write. Differentiation of minus x square will be minus 2x. So 2 and 2 gets cancelled. So you get minus x by root of 1 minus x square. Fantastic problem. Simple, isn't it? Now the next question. This is a very, very nice problem. Okay. What do I do with this problem? This is the last problem. Let's try to simplify this. This is y equal to tan inverse of, denominator is plus, so numerator should be minus. So can I write this as 5x minus x divided by 1 plus 5x into x. 5x into x. Now this what I do, can I write this as tan inverse of 2 by 3 plus x divided by 1 minus 2 by 3 into x. What did I do? I divided numerator and denominator by 3. Okay. So now here I take 5x as tan A and I take x as tan B. So what do you get? I get tan inverse of tan A minus tan B by 1 plus tan A tan B. Let it be there. Now here what I do? I take 2 by 3 as tan C and I take x as tan D. So don't think of this x. Let us say, let's deal with this separately. So this will be tan inverse of tan C plus tan D divided by 1 minus tan C tan D. In fact, if you want, you can write it as tan B, no issues. Now this is nothing but tan inverse of tan of A plus B. This is tan inverse of tan of C plus D. Now what is this? This is A plus B. This is A minus B. I'm sorry, A minus B. This is C plus D. Now what is A? A is tan inverse of 5x. What is B? tan inverse of x. What is C? Tan inverse of 2 by 3. And what is D? Tan inverse of x. Tan inverse of x, tan inverse of x gets cancelled. Now differentiate. dy by dx is tan inverse is 1 by 1 plus 25x square. Correct? 25x square. And differentiation of 5x is 5. Plus 0. Because tan inverse of 2 by 3 is 0. So I think we have covered few questions in inverse trigonometry. If I get more interesting questions in inverse trigonometry, we'll do more on that, or otherwise we'll go to implicit differentiation. I hope this video is useful to you. Kindly subscribe to my channel and also click the bell icon to get notifications of all videos that I post. Okay, I hope these sessions are very useful to you. Okay, keep working hard. Have a nice day. See you again in the next class. Bye bye.